So dear friends, in this video we will solve the question for the amount of oxidizing agent. This is the oxidizing agent. K2Cr2O7 is an oxidizing agent. Determine the amount of K2Cr2O7 required for required to produce 5 liter of CO2 at 75 degrees centigrade and 1.07 atmosphere pressure when treated with excess of the oxalic acid. Means when potassium dichromate is treated with oxalic acid, then for production of 5 liter of CO2 at this temperature and this pressure, how much amount of dichromate is required? How much amount of dichromate is required, potassium dichromate is required to produce 5 liter from the oxalic acid. So we have to calculate the amount. So this is we know that from this question can be easily solved by the law of chemical equivalence. Means equivalence of the reactant is equal to equivalence of the product. So equivalence of dichromate is equal to equivalence of CO2. So what is the formula of equivalence? N factor into mole. N factor into mole. N factor of the reactant is equal to N factor of product. So what is the product? Product is CO2. So we can find the number of mole. So number of mole of CO2 can be calculated by formula PV equal to nRT. PV equal to nRT equation. We can calculate the number of mole, and by putting the given data we find the number of mole is equal to 0.187, and the N factor for this is N factor. As we know, the oxidation state of carbon in oxalic acid, in oxalic acid is +3 and it's changed to +4. So difference in oxidation state is 1, and here it changed from +6 to +3. So per mole it comes out 6. Per atom it is +3, but per mole, as this has 2 mole, per mole it has 2 mole of atom, so it comes out 6. So the oxidation state is 6. So the N factor is for oxidizing agent is 6, and for this is 1. Sorry, for this is N factor. N factor for this is 2, because there are 2 atoms. For per atom there is difference in 1. This is +3 +3 to +4. Oxidation state difference is 1. For per mole is 2, because there are 2 atoms. In oxalic acid, carbon atom are. So the N factor 6, N factor is 2 but for CO2, because there are in CO2 there is one atom, but N factor for oxalic acid is 2, but for CO2 is 1. So because the number of carbon atom per mole is 1, so the number of mole of K2Cr2O7, we first calculate the number of mole and then we convert it to mass. So the number of mole is equal to number of mole from the number of mole of CO2. The number of mole of CO2 is 1.87, and by rearranging it, the number of mole comes out 0.0312, and the mass is equal to mass. How we will calculate the mass? This is the number of mole. So mass of 1 mole is this, so mass of N mole is this, and it comes out 9.1728. So if the number of mole of one product is given, then we can calculate the number of mole of the reactant by the formula of law of equivalence. From the law of equivalence, number of mole of the reactant is equal to number of mole of the product. Sorry, number of gram equivalent is equal to number of gram equivalent of the reactant is equal to number of gram equivalent of product. And in this way, by putting the value of number of mole of the one reactant and the n factor, we can solve this, and we can calculate the number of mole of the other, and by multiplying the mole into molar mass, by multiplying the mole into molar mass, we can find the weight. So I hope it is clear to you. Thank you.